Saxon's Trig, lesson 22, is about absolute value and reciprocal functions beginning on page 160. Absolute value is in two straight up and down lines, and you basically just have to intuit whether you're being given absolute value or another mathematical symbol. Usually it's fairly easy to tell. So if you were given something and then it's got a -3 inside, you need to remember that absolute value can only have positive answers. So the absolute value of -3 is 3. The absolute value of 3 is 3. If I give you something like the absolute value of x minus 2, then I need to figure out what my values are. You wouldn't just say equals x plus 2. I'd need to give you a little more information for you to solve. So if I said it equals 4, now it's an equation. This I can solve. But I know that when I solve it, I have a positive answer and I have a negative answer. I can have two different answers. So we would solve this by saying x minus 2 equals 4. No change to anything will give me my positive value answer. When I do my negative one, I tend to keep this part the same, even though it's the one that can have the negative answer. And I change this answer to its negative format in order to solve. So one answer here would say x is equal to 6, and this one would say x is equal to -2. Will both of those answers work? Well, let's try it. 6 minus 2 is 4. The absolute value of 4, 4. -2 minus 2. Just a second, did I make a boo-boo here? I might have. Because that came out 0. 0 is not 4. No, I did this backwards. I should change this one. When it's greater than or less than, I can get away with this, and we'll do those later. So this should remain 4. Okay, now let's check that. -x, 4 minus 2, 2. Yes, because then this changes. X equals 2. No, still have a problem. 2 minus 2 is 0. This answer does not work. What am I doing? Hang on. That's what I did, figured it out. It was in my changing of signs here. So when I made this -x plus 2 equals 4, 4 minus 2 is 2, this negative wasn't existing. Then when I fixed it, changed it to -2. -2 minus 2 is -4. What is the absolute value of -4? 4. So there are two answers, the 6 and the -2. I knew it should work. Okay. Now, they are not talking about this equal information in this lesson. They're talking about greater than or less than. So they're going to, in one of their examples, they have the absolute value of x is greater than or equal to 3. How does that graph? So I know that I need two different answer sets. So if I do the normal one, no change, ignoring the absolute value, then here's my 0, here's 3. I have an equal, therefore it's colored in dot. Greater than means I'm heading this direction, higher than the 3. Now what about the negative value of it? So I'm going to do x is, and because I'm negating the answer, I'm changing the symbol and making it this. There's no rearranging then. So here's the other negative answer set. Go to -3, it's definitely colored in because of the or equal. Less than is going this direction. This is the graph for the absolute value. It goes in two ways, the positive answer and the negative answer. It works the same way if they give me no equal. So the only difference is if there's no equal sign here, instead of colored in dots, there will be open dots and the solid arrow. Open dot and the solid arrow. And I may have to do some other rearranging if they give me something like x. Oh, I don't want to do their -a that they're doing there. I'm going to jump to example 1. the absolute value of x minus 2 is less than 0. Graph this is what they ask us to do. So first I'm going to solve for the absolute value of x by moving the 2 over. Adding or subtracting does not change the symbol, but multiplying or dividing by a negative would. So I need to do 2 answer sets, the positive answer set, which will look exactly like it was, and the negative answer set, which will be x is, and change it to greater than -2. Flip the symbol, change the sign, and ultimately they wanted me to graph that. So 0 to -2, no equal line, so I will have open circles on these, less than 2, that's headed this way, and greater than -2 is heading this way, so now the solid line actually connects in between them. Example 2. Graph the set x is an element of the real such that the absolute value of x minus 5 is less than 2. We want to solve it both ways. So we're going to do exactly as is for the positive answer. So x is less than, add 5, 7. And the negative solution, x, and this will work when it's not the equal sign. So x minus 5, I leave the same. I flip the symbol and change this to -2. So x is greater than, add 5, 3. Here's the negative solution. And it wants this graphed. So here's 0. 1, 2, 3, 4, 5, 6, 7. Here's my 7, here's my 3. No equal line, so open circles on both of those. I am less than the 7 and greater than the 3. So again, that's joining in between. Example 3. Graph x is an element of the reals. Absolute value x plus 2 is greater than or equal to 3. So my positive one, x plus 2 greater than or equal to 3, solves -2 is 1. Reversed negative solution, flip the symbol, make that negative. Now solve less than or equal -5. On the number line, 0, 1, 2, 3, 4, 5, -5, and 1. Or equal to, colored in for both of those, greater than 1 this way, less than -5 this way. So now they're going in opposite directions. Darken that just a little bit more. Sometimes it's hard to tell with the pen if it's dark enough or not. Pencil's easier to darken in. Example 4, sketch the graph of y equals the absolute value of x. I need to know that the absolute value, it's like before when we did square roots, we knew they graphed curves. Sorry, that's lousy, it should have an arrow. So a starting place and an arrow. When we graph absolute values, I need to know that it basically graphs a V each and every time. So I would just mentally pick my x's and match them with their y's. If I pick 0, I get 0. If I pick 1, I get 1. If I choose -1, I get 1. If I choose 2, I get 2. If I choose -2, I get 2. And that's the V that's being graphed. Part B is about reciprocal functions, and reciprocal means I've flipped something over. And they go through some darkened words here on page 162 about a vertical asymptote. All right, so basically what they're trying to say in this reciprocal is if we have y equal x, it graphs a line. And if I do its reciprocal, I'm doing 1 over x. I flipped the x value. And so what am I not allowed to have in a denominator there? A 0. And so this is not an answer I can get. So when we did that before, we do dashed lines, but when it's one of the axes, we don't change it to dashed. We're just making a mental note that this major axis, the y-axis here, is an asymptote. So instead of having a line as it would go up, it would curl here because it can't touch it. And the same thing would happen on the other side. Now, I would not graph the original and then try to match the points, but that's what they're showing you about what is happening here. I would, however, just do my basic chart and pick things. I can't pick 0, but I can pick 1, and 1 over 1 is 1. If I pick 2, 1 over 2 will graph a half. If I pick -1, I'm going to get -1. So let's see what this looks like at this point. 1, 1, 2 is halfway, -1 is, just a second. Yes, I am allowed to pick negatives. Why did they only show me? I'm going to ignore that one for just a split second. I'm going to finish this graph. So I know that as I get closer and closer, it's going to skew up this axis. And I also figure that if I plugged in a 3, I would get a third. So I'm getting tighter and tighter as I approach 0 here. So I'm not going to cross this axis. I'm just going to get tighter and tighter to it. So here's the graph. I know what they just didn't show you the other half. Oh, they did. They did it separately. Let me graph the -1, -1. Okay. Then the same kind of thing would be happening. If this went to -2, this would be -1/2. So that's halfway. That's here. So the tighter I get to this axis, the closer to 0 I get. And obviously the more I go here, I can't touch it, so it skews me down. The combination of those two is their full graph of the reciprocal, which is on the bottom of 162, and that's what threw me for a second. I was like, that can't be the final answer. Final example in this lesson is example 5, and it says sketch the graph of y equals 1 over x squared. So I'm going to choose some values. The first thing I know is that I can't choose 0 because that's going to make a 0 in the denominator. But I can choose 1, 2, we'll do a -1. Oh, I might even do a half on this one. Okay, so 1 squared is 1, 1 over 1 is 1, 2 squared is 4, so this is 1/4. 1 over -1 squared is 1, 1 over 1 is back to 1. A half squared to a 4th, 1 over a 4th flips that, makes that 4. Since I know that this is the 0 axis, it's an asymptote, I can't use it. So I'm hoping I have enough space if I do it that way. Try to make these wide enough to actually match. Okay, 1, 1, 2, only graphed a fraction, -1 graphed the 1, a half went all the way up to 4. So again, this I know, the closer I get, the tighter I become here. This as I come down, again tells me that I'm going to get closer and closer to 0, but not touch. I only had 1 dot on this side. However, if I negated to -2, I'm going to get -1/4. I think that's right. No, wait a minute. -2 squared. No. It's still 1/4. -2 is 1/4. So tighter and tighter here to the 0. This is obviously going to come up. And if I wanted to prove here on the -1/2, that's also going to spit out 4. So that's going to be way up here. So it's going to be super tight.